Friends, welcome to the graveyard of great ideas. Every world-changing revolution starts the same way, with a genius in a lab asking, "I wonder if we could..." It's a beautiful, pure moment of human curiosity. But then, the heavy oak doors open, and in walks a guy in a tailored Patagonia vest carrying a spreadsheet. This is the moment a scientific discovery tries to become a business model. And let me tell you, that is usually where the funeral begins. Today, we're peeling back the shiny 3D renders of the two biggest mirages of our decade, the Hyperloop and the hydrogen car. On paper, they are masterpieces of human ingenuity. In reality, they are expensive lessons in why you can't use venture capital to bribe the second law of thermodynamics. Is it a failure of genius, or is it a failure of context? Let's find out. Let's start with the big one, Elon Musk's 2013 Alpha paper. He didn't just propose a train, he proposed a way to ignore air resistance. Genius, right? If you remove the air from a tube, you can shoot a pod through it at Mach 1. Now, Musk wasn't naive. He knew about the Kantrowitz Limit, the aerodynamic law that says if your vehicle takes up too much of the tube, it becomes a piston choking on its own compressed air. Think of it like trying to blow a marble through a straw that's barely wider than the marble itself. So he designed the pod to be only about 36% of the tube's diameter, staying safely under that critical threshold. Problem solved, right? Not even close. Even respecting the Kantrowitz limit, you still face an engineering nightmare. You need massive compressors on the nose of the pod to shove air out of the way. That adds weight. To handle the weight, you need more levitation magnets. More magnets mean more electrical resistance, which means more heat. And now you need a cooling system inside a near vacuum. It's like trying to cool an oven inside a giant thermos. From a management perspective, this is what we call a resource pit. A high-speed rail is an open system. If a track breaks, you fix that section and move on. The Hyperloop is a closed system. One tiny seal leak in a 300-mile steel tube, and your $10 billion asset becomes a very long, very expensive vacuum cleaner that doesn't even clean. And here's the kicker. Musk open-sourced the idea. He didn't build it himself. Virgin Hyperloop, Hyperloop One, and others took it up. They raised billions. They hired the best engineers money could buy. And yet, as of 2025, not a single commercial passenger route exists. In fact, let me give you the epilogue. In December 2023, Hyperloop One, the most well-funded Hyperloop company, officially shut down. After raising $450 million over 9 years and hiring hundreds of engineers, they achieved a top speed of 240 miles per hour in tests, not the 700 miles per hour Musk promised. They secured 0 commercial contracts, 0 revenue, 0 operating routes. The test track in Las Vegas being dismantled and sold for scrap. The intellectual property transferred to DP World, the Dubai port operator. The employees laid off on December 31st, 2023. From transportation revolution to asset liquidation in under a decade. The pure curiosity of the engineer created a maintenance liability that no spreadsheet could ever justify. This wasn't a business, it was a 10-year science fair project that ran out of lunch money.
But here's what really killed the Hyperloop. It wasn't just the physics. It was the economics of keeping a 300-mile vacuum sealed. Every single joint in that tube needs to be perfect. Every weld, every seal. One failure means the entire system depressurizes. Compare that to a train. If one section of track fails, you reroute. The system survives. If your Hyperloop tube fails, the entire route shuts down. This is what engineers call a single point of failure nightmare. And then there's the thermal expansion problem. A 300-mile steel tube in the desert sun can expand by several feet. You need expansion joints every few miles, each one another potential leak point. And we haven't even talked about earthquakes.
California, where most routes were planned, averages 10,000 earthquakes per year.
Even a minor tremor could misalign the track by millimeters. At 700 miles per hour, that's catastrophic. The safety requirements alone made the project economically impossible.
Virgin Hyperloop's own studies projected ticket prices would need to be 2 to 3 times higher than flights to break even.
Who's going to pay triple for a train that goes through a tube? The answer: nobody. This is the tragedy of revolutionary innovation. It demanded the world build a trillion-dollar stage for a technology that wasn't ready. Meanwhile, high-speed rail, the boring solution, actually works. Japan's Shinkansen has carried 10 billion passengers over 60 years. 0 passenger fatalities from accidents. Average delay, 54 seconds. China built 25,000 miles of high-speed rail in 15 years. It carries 2.3 billion passengers annually. It's profitable. The Hyperloop? 0 passengers, 0 revenue, 0 miles of operational track. This isn't about innovation failing, it's about ignoring the lesson of successful innovation. The best technology isn't always the most advanced. It's the one that works with the infrastructure we already have. That's why electric cars beat hydrogen. That's why Zoom beat Google Glass. That's why high-speed rail beat Hyperloop. The engineers who built the Hyperloop were brilliant, but brilliance doesn't override economics, and it certainly doesn't override physics. The Hyperloop failed because it required perfection, perfect seals, perfect vacuum, perfect alignment, perfect materials. Success requires the opposite: robustness, redundancy, forgiveness for failure. That's not sexy, it doesn't make for good TED Talks, but that's how you actually move 2 billion people a year. The Hyperloop was a beautiful thought experiment, but thought experiments don't transport passengers, they don't generate revenue, and they don't survive contact with reality. In December 2023, reality won. The test track is being sold for scrap metal. The engineers moved on to other projects, and the world kept riding trains. The same trains we've been riding for 150 years. Because evolution, not revolution, is how infrastructure actually advances. One upgrade at a time, one improvement at a time, not by demanding the world build a new universe. That's the lesson of the Hyperloop. Pure curiosity created a masterpiece of engineering, but masterpieces don't always make good businesses, and they rarely make good infrastructure. The spreadsheet didn't kill the dream, physics did, and economics buried it.
$450 million, 9 years, hundreds of brilliant engineers, and in the end, a pile of scrap metal in the Nevada desert. That's the price of ignoring reality. This was the Truth Project. See you in the next one.
If you have questions about any of these topics, or want me to dive deeper into specific areas, leave a comment below. Your curiosity and engagement help shape the next videos I make. The more specific your questions, the better I can address the real issues you're facing. Drop a comment, share this with someone who needs to see it, and let's keep building understanding together.